Hello. Welcome to another video where we're going through and implementing VT500 series parser. So this is a old terminal. Those are pictures of older ones like the VT100, but the gist is that you've basically got a this might have one actually. We scroll to the top. That didn't scroll to the top enough. No pictures. But yeah, it's basically an old terminal which connected to a mainframe, which pretty much every terminal emulator emulates that terminal. So I thought I would give it a go at emulating it, see how far I can get. So the last episode, I kind of made it so we can have multiple input streams, so we can have ability to resize, and then we can print stuff as well. What I kind of want to do is extend that a bit and start showing the kind of output of what the terminal is actually looking like. So to do that, win size, I need to make sure that the win size is actually a bit smaller than the a bit smaller, so I can kind of show some header and footer information, if that kind of makes sense. So at this point here, the larger window size. So what I might do is we can call this the outer window, and in the window we redo and what I wanted to do. Cool. So at this point here, we would need to say outer window. Use that. We can say window. Use that, and yeah, we can just say what the outer window is. Outer window size. So here we can now say that the inner window size. So VT. Inner window ws co equals VT outer window dot ws co, and let's remove I think I want to have like a grid on the left and the right just to kind of highlight where things are, and so on the left I want to show like 1 to some number, and then on the top I want to show 1 to some number, and I want to be able to see like easily the tens columns of all these things, I guess. So how I might go about that is having like 2 digits on each of the kind of gutters. So I think I need to subtract 3 from the column and then also the row, and then the inner window size. So if we go to there and C2W and then one that again. So now it should be able to. Interesting. Yeah, that's what I haven't done. I've got a few things that kind of make my C programs a little bit nicer. I think one of which is going to be the void reload if source newer. And this is going to take in the char start So maybe take in a const char star, because I believe these are meant to be const like that. I don't know that. But this is going to be the program, and then we're going to take in an int c and const char star b. And what we're going to do is we need to do some stat. So to do stat, we need sysstat. So in here we can find the I and then stat there. And so stat is going to basically return a struct stat. So we're going to have a struct stat, and this can be prog stat. We can also have a file stat. And at this point, I'm going to make the assumption that there is only one source file. It's just how I'm going to do it. So this will return us some values. So return, what will it return? -1 on error. So we just need to go stat, path name, and the buffer. So if this whole thing equal to -1, we can return. And this whole thing is going to be the file name of the program. And it's also going to be the I just realized that it potentially won't hit things. Because if it's in the path in your argc, your program might not actually be the real path to that, I guess. And so we can also do the same with file, and that should be right. So, and then if prog stat.m time is that what I'm looking at? And do we say what the thing is? Stat3 type. Okay, so if we go 3 and then that, this gives us hopefully right one. Sometimes navigating these things are impossible. Yeah, so like we need to get stat3 type, which that. And so what are we after? We are after intim. And it's a time spec. And so time spec has two values. So TV and this was the correct time. ST M10, so last modification. Now, if the seconds of the program is less than the file stat.st m10 tv deck. So if the seconds are smaller, or the prog stat dot m stnton dot tb tb sec equals file that dot stnton dot tb bit and prog. Gosh, this thing's so now this is going to be TB USEC is less than TB USEC. So if that is the case, then do some rebuilding. So if it is needing to be rebuilt, what we need to do is, I think I was just doing system, which just takes a command, but we could like do things a bit better, which like execl, which will kind of just take in things, or even, I mean, it requires a path name to fix me. This won't work if program is called by which makes me have to go with the things. But what I kind of want to do is just do so we have a make that sort of thing. So we can do something like that, find that. And then this is going to be the file. But here we need to like kind of say -o something. So what we could do is const c flags equals, and we can just kind of put in our flags there, and then we can we also need to have and this is going to be strlen of c flags plus 3 for, I mean, I might just do cc have a gap between them, and then we want to have a get my hands in the right point, and here we can have strlen of file, because we know that, and then we have a -o with like some spaces, so +4, I guess, and then plus strlen program, and like that's going to be the length of the whole string, and then we want a +1 because we need a null byte on the end. So if not str, we probably want to just return. We can't get memory to even allocate string for a command and then call Now what we can do is AS printf. And what we could do is strlen equals, and then we can like see that the camel. And strlen, and then we can do that sort of thing. And perhaps we can do the +1 for the null byte there. And then ASPrintf, we want to pass into str, and then we want to pass in cc, our flags, our file, and then -o, our binary, and then that's going to be our whole string, and we're going to have cc, c flags, file, and then program. And I think if this is not equal to strlen, it kind of means that we didn't write everything. So what I might do in this case, and maybe put that there, is we need to free str and then return. Otherwise, we can we'll system on it. Now, system will return just the error code. Is it? I could not be that. Yeah, I think that's probably that. So int ret equals that, and if not ret, that means that something kind of failed. We probably want to, at this point here, we can free str, and then we can just return. We can just return in that case. Otherwise, we can go XECL, CL, the one that I want. CV, I think, is the one because we have yeah, we have the path name and the arg feed. We don't actually need the arg. Cool. And I think here we can do the CVP because then it will look it up. P. So if we had the P, duplicate blah, looks up stuff in some sort of path thing. And so here we can pass the V. And here this is unreachable. Wow, is it really? So it can only return in EXECVE. Okay, EXECVE. Was that not just right? So it could have like a bunch of errors. Could it have interrupt? Do we care about that at this point? No, but it could have some errors. Ret equals. I think at this point, we just want to ignore it maybe. If it works, it works. And we free that after there. Then it should just do that. So here we can rebuild, what do we call that? Reload. Reload. Source newer, and then we can just pass in the argv. I think something like that. And then this will probably main. And I think I want to do that. Cool. So if we build this once, we don't have that. Does it not have time spec though? Time spec in second. SRU sec with in sec. Right. So these are child stars. We need string. We need string.h. strlen is from string.h, and it takes a const char. Yeah. All right. We've got a const char star. Yeah. And you need string.h. What is the malfunction here? C. C is just what it is. Right, so now it still recognizes that we have not cleared this in any way, but we have a string, but then didn't. Yeah, so how do we get about this? What one do we want with a just const star? XACBE. What was this one? Had expected. This sort of nonsense. And it doesn't want this const. So don't even give it. And so this is that sort of thing. Cool. And so now, if we go like this, and potentially we could just give it a little warning, if into. And so if we do this, in fact, if we run it now, it reloaded, trust me. If we do it again, so if we just save that, Interesting. Do we never actually do this? So, that wasn't the one I wanted. That either wasn't the one I wanted, that one was the one I wanted. So if we go brick name, layout, source, so we'll debug this bad boy. So if we step into here, I would expect, yeah, so we have a path to where we are, and then IV is doing some things. That's all good. In fact, if we look at IV, that's that. If we look at IV one, there should be a null. Perfect. So if we do these two stats, we should get where in this case. Cool. So here we should. Does AS printf? Yeah, AS printf is not what I want, I think. AS printf. No, we just want S in printf, which takes a string, then a size. String, then a size. So if we compile that once, now if we touch that file, it should be doing some compiling. So if we run, yeah, if we break main, then run, yeah. We are in this point here. So I want to step into this. We can't step into it, but it got past that point. So if we like look at SDR now, we should get that whole thing, and it's cut off that out. Space minus O space. Is that what I want? It feels like a little gross, but what I want is it to initiate a rebuild. And I also want, so there should be a dot now. So if we go into here, layout, source, main, we can run that, step into that. So we should, at this point, have the whole thing. Why is it cut off there? Do on something like that. Um, break VT C and center nine. So if we just run that to there, yeah, that's fine. So it still doesn't like that. I kind of want to know what it is. Um, cool. So it broke that. So if we go into here, go here, break t.c and 740. If we run that to there, we should have at this point here some value for there, and we have that. So I guess we are 1.8 len minus 1, just is what it is. So we can do something like that. Right, so now if we go back to 739, rate VT.c 739. So if we run that to there, so now we should have the whole thing printed out. Cool. So now that should do some things. Cool. So now what we can do to test this, we can just go like, I don't know, printf, I'll just save it and then run this. Didn't do anything. Save, run. I don't know. Um, I swear it works. Cool. So this rebuild if newer is and then here we can just pass in that string. What is it that it's trying to call? What are these? Do something like that. Cool. So if we that looks right. All right. So, but it never wrote this thing if we cool. So now if I get rid of that and run it, reloading is new server. So if I bring that back in and bring in the rest, it'll reload the whole new source. Then from that, took a bit longer than I thought it would, but we'll keep in the one message just so we can kind of see that. So I'll put this right there. It'll reload with that new source. Cool. So when we get the new source and whatnot, this is when we get the inner and the outer. So what we kind of want to do is have a structure kind of holding everything there. So what we kind of want to do is we probably want to have a VT cells, and we'll have a pointer to it because we'll kind of need to assign it and unassign it on the fly, or using malloc, but that's all good. So if we create a VT cell just to kind of what it is, all it's going to have in it is it's going to have it could be blank, which it starts blank. So I kind of want this to be used, and then if it is used, it has a chart that it can print out, and it can also have a attribute of some type. So we could probably just have VT attribute and we can just define an empty VT attribute there. They'll have stuff like color and italics and all that, but for now we'll just have VT cell. So when we do the resize, we kind of want this to be resize window, and we can kind of call it like that everywhere. So if we are resizing it, we kind of need to see whether we currently have some stuff. So we would have VT cells original equals VT cells, and we will free this if needed. And I probably also want to have a struct win size original size equals, and this can just equal to inner window, because we're kind of mapping what's on the inside. We don't really care about the outside. In fact, like we could almost ignore the fact that we have an outer window, and perhaps we could just have it something like this, and if we have that, and then here we can have, if we search for that, then do that, and we can just do that, and then do the same there. And then here we can say what it is for the inner window. So if we find I, then window, and then find I, and do that. Win size. So here we only really care about the one window. And so that kind of means that we can kind of see if there is existing stuff. So if there is existing stuff, we kind of want to how do we want to do it? I guess like we just want to overflow everything that is currently there. So we would go through each row of the existing one and append it to the new one. And so what's calc order one? It's numbered in size. So we're going to have, and So this is going to be window.ws co, and then this is going to be VT window dot ws row. So just rows times columns, or columns times rows in this case, and we're going to have the size of, and we can do a fancy trick here where we can just kind of refer to this thing that we looking at. And so that means if we kind of change the type of what that is, we don't have to change it at every kind of point we're checking what the size is. So after we kill it, that means that all those cells are now in an empty state. So they should be all unused. In the char and attributes will just be blank. But if it's not used, then it's all good. So what we kind of want to do is we just want to go through in fact, like we could almost just mem copy it, as long as we don't copy more than what we had and to more than what we have. So what we can do is size t max size equals, so this can be vt, well, it really only matters if we have an original. So if we have an original, we are going to do some things. And at the end, we are going to free original, because we are the only ones that have that reference now because we overrode it there. And if not VT cells, we should, if we have original, perhaps just set it back. No, I think we should free original and then return, because we can't really do much more. So this is going to be original size, and this is ws co times original size dot ws row. And so if we get that, so orig size in new size, and this is going to be replace original size with VT window, and I believe that's all good. So size t max size equals rig size. If that is greater than new size, then we want new size. Max size to copy. It's really the min size. So if the original size is greater than the new size, then we want to give the new size. Otherwise, we can give the orig size. Something like that. And then we can do mem copy from two VT cells, and we want to copy from original and min size, something like that. I think that's kind of what we want. Because of the way it's set up, that should automatically just kind of wrap everything around, because when we query it, it will be in that kind of size. Cool. So that means that theoretically, every time we reboot, so this I think I want this to. So I think if it's I think I want that, but of course I can't do it now. We can't do struct with no members. We'll just call an I. We'll get rid of that at some point. VT cell, it's just a thing. You didn't do it there. So this is greater than 3, and this is also greater than 3. Well, that's annoying. Cool. So now this should do that. And now if we, I don't know, do like a syntax error, it should just kind of crash out rather than trying to just run the old version, which is what was kind of doing there. And then it's a bit nicer there. You might also notice that because I'm just doing just new line, it's not kind of padding to the start of the thing. It's actually like kind of because we're in raw mode. It's just how it is. So now that we have this, maybe we'll do that. We can compile that just to get rid of that. So now we should have kind of copied everything over at each thing. And so what I kind of want to do is redraw, like show the window, I guess. So I guess at some point we need to show the window. And I kind of want all of this kind of helper function stuff to undo that, redo that. I kind of want all of this like from there almost all the way to there, and have it somewhere kind of closest to this point here. I wonder if that will kind of let me do that. It will. Cool. And that way we can kind of get things a bit nicer. I don't know if that's nicer or not, but it is what it is. Right, so resize window. After we resize, we want to redraw window, or like just draw window, I guess. And yeah, draw window. We'll start with a version that is potentially flickery. So potentially flickery version will kind of, it'll draw the grid and then go through and draw each of the characters with whatever attribute that they have at the time. Which, yeah. So, when we draw a window, we had a TTY, I believe. So we could probably test that by I. And if on resize we will we'll just draw a window and pass in the VT context. That way it should redraw on every time. And so hopefully it will start saying hi whenever we kind of redraw. Cool, it's printing hi. So what do we want to do when we redraw? This is kind of when we start getting like into the ANSI functions, which this whole project is about parsing them, but I'm also going to make use of the fact that I am in a terminal, and I'll make use of that terminal's functions to then display my thing. But then it'll make sense. It'll make sense. But so what I want to do is basically clear the screen. This one here might be a better reference, which is just this. So what we want to do is this erase and display, and we can set the cursor, but this kind of has like if n is 2, clear the entire screen. So I think I want to try just see if that will do the thing. So 033, and then it's that, and then nj. So we'll have 2 in j, and we'll see if this prints just at the top of the screen. It prints it kind of at the top of the screen. It prints it at the bottom, but it clears the whole thing. So what we can do is start defining clear screen, and this is going to be just that. Move that and get rid of that and get rid of that. So in here we can just go clear screen. Another thing that we might want to do is go to, and we can probably pass in an X and a Y. And perhaps we can VT ED, do something like this, and program, and then we can do something like that, and then clear screen can just be VT ED 2. That is just how clear screen works. And so CUP is cursor position. So we can call this VT CUP, cursor position. And so this can be, and again, the single cache here is turning it into a string, which you can just kind of append like so. And it was H, I think, H for that sort of thing. So we can start going to like, we can call this X, Y, and it can just work out that. So some nice names for them, and then some bit less nice. So here we can now go to 1, 1. So it's all 1 based here. But now if we go printf VT TTY hi, we should get that up the top. And I was thinking, other applications I've done kind of make use of the hot reload. So at the time it detects that the source is changed, it will actually automatically reload back in, which potentially I want here. I don't know. How you would do it is basically whenever you do the in the main loop, when you do the select, you could have a timeout, I guess, to the select, and then you also check the rebuild if necessary in this point here, in which case you would have to pass in the all the stuff. You can even keep the VT object around, which is quite handy for some situations, but in this particular setup, it won't. Like you basically have to store pointers to the memory and then load the thing as a dynamic library. So you would compile this file as a .so file, and then you would load that as a library. And it would include everything but main, I believe. And then in main, you handle everything that you need to do to get into that dynamic library, which is basically looking up a function name by name and then chucking it in. Anyhow, if we maybe have a look at this height thing again, I kind of want to draw some rulers. So across the top of the screen, I want to draw in the first line. I don't want it to be too busy. Like I don't want it to be like 0, then 10, 11, 12, 13. I kind of want it 0 to 9, 0 to 9, 0 to 9, and then up the top just a 1, a 2, a 3, just on the 10, if that kind of makes sense. So what I kind of want to do is we want to go to x, y. So we want to go to 3, 1, which 4, 1, 4, 1. And this is getting to a point where this size here, I kind of need to know, like up here, because that 4 is actually 3 plus 1. But I think I'll hard code it for now. But the go-to, I kind of want to be in line, so we can do something like this, and because then it'll kind of bundle them up. So I want to go to 4, 1, and then I want to go from 4 size t. So this is going to be the row I'm in, so we'll call it y equals 0, we'll call it y equals 1, and y is less than, and we have a VT window dot ws col, something like that, and then y plus plus on that thing there. So in this top row, I kind of want only to print the tens, I guess. So I could perhaps even do so like that. And then here we don't really need to care about the go-to. So here we can printf. So here we're going to pass it to lbtty. And we can go to, so we're going to have like 3 plus 10 times y, I think. And then we're going to pass in just a number which is going to be y divided by 10 mod t. So we won't see the hundreds, but I think that should be all right, because if you do have the screen wide enough to get the hundreds, it will just go back to 0. And it should show 0. Yeah, I believe it should show 0. Right, so at this point here, we have done that. Now we can probably go to 4, 2, 2 even, and then do another loop. But here we just want to go up by 1 every time, and here we don't want to bother with any go-tos, make it slightly cheaper, and here we just want to do the y mod 10, and so that should show the bottom digits. And so it doesn't work. What doesn't it like about this? Right, so it wants this to be LD, doesn't it? So that kind of looks all good. I think I might just reset that just to see where we're at. Doesn't quite look right, because what is happening is we're not getting the top bar. So it's as if it's not so maybe after an exit we can just exit 1. So our we get nothing to our output. So VTTY so we're just running direct to the TTY there. I would have thought that, like, I feel like the go-to is not working. I mean, what I could do, it's done that. I can do a GCC of this whole thing, and then if we go to like a if printf, where do we do things? There, here, this looks good. So we are doing our clear, which is just that. And then here we try to go to, yeah, so this is not working out what it is. So we kind of need to work out what it is. I think the go-to, what we really want is it's annoying. Yeah, I mean, I get why, but like, I've got a number and I want it to be a string. In macros, you can turn it into a string if it is a plain number. But not if that's like an expression like this. Like we almost need to do something like that, and like that should also probably be I wonder if I want something like this. Do something like that, and then you kind of have to give it something like that. In which case, we also kind of want to put brackets there. And then here we would have that, and then no, do something like that. I wonder if I could pass in extra stuff. Like not easily. You can, but I don't know. Cool. So if we go here, then here, then here. Cool. So now if we kind of run this, that'll like a bunch of things. I think I'll just expect this for all of them, and then didn't really want that. We'll just call this and as well, and that and as well. I don't imagine them going up to like a million millions. Right, so if we do that, and that would be do the same there. Cool. So that is now all compiling. We run it. It doesn't quite get what we want if we set it. We run it into a XXD. That also gets nothing. So it's kind of like the TTY is TTY equals in this case here. Printf std error name error TTY. So like why? Um, does not a picky bird, picky bird. Um, and then that can be error. It's just easy. Yeah. All right. And then it knows it's. So I wonder if I always want to send to that, but like. I think I just want to always hard code it to be that. And then that way we can kind of see some of the output that is happening. So 1031H doesn't seem right to start with. I think I just wanted that. Who would have thought it would be this hard? I kind of want to just try and get that first line going first. So it's kind of, yeah, I think it's the XY is actually YX. That looks better. No, that looks better. And it's above all the zeros, and it stops at that point. It potentially could go one more because it is one based. Only because. All right, cool. So if we have that, I now want to print a line kind of underneath that, which has a corner thing. I don't know how to describe a corner. Do we have oh, we'll do old school. So starting from one less, I want to print out plus at that point there. And then can I do that sort of thing? And then say if I had two and then did that, we get two. If I only keep one in the string, it will do something weird. So we kind of need to have that done differently. So I think I just need to print character by character. And so this is just going to be, you can just print A. Something like that. Boom. Except we leave one there. Looks cool. So that means we have 3 lines taken up, which makes sense there. 1, 2, 3, and we go right to the edge. Oh, and then we get that 7 there. That looks pretty good. I like that. Now we need to do the same down the side, which requires a few more go-tos, but it is what it is. So if we, so we'll have x, and X there, and then this is row there. So at every X point, we want to go to the first column of the third plus X line. And then here we can print here. And this can be, I guess, X. And this will print like two different colors. So we'll have to kind of suss that out. So when it prints the 2 digits, we want to, if X mod 10, if that is a thing, then we just want to do that. So I guess we can get the mod. That's so that is if it's not on a 0, and if it's on a 0, then I kind of want to print a 2-digit bit space with 0 spaced. That kind of makes sense, and doesn't do anything. We'll see if it does do something. So this we want to print the whole thing. Now I kind of want to know what happens if I have like, hey, that kind of goes back. So it's a bit small to see, but if I go past 100, well, we can zoom back in. If I go past 100, it will start printing that, which isn't what I want. So I think I want to do that sort of thing. And so now if we zoom out lots, so a bit more, that does not quite do the trick. So here we got 90, then 0. So I want that to be 0, 0. Now I guess that is because it exactly equals 0. So what about in this case? Hey, that looks good. So if we get back to, we get what that would have got me there. Right, so if we look here, we went from 90 to 100, and that's just 0, 0, and then 110, 120. And I think that's spot on. Right, so then we also need a little bar. Gotta have a bar just to show what's what. And that is kind of covering the whole screen as I would expect it. And this prompt will just not be there. there's potential I'll cut off some of the side or some of the bottom just to show what else is happening. But for now, that is that. And so what I can do is maybe I'll start on the print action just because, yeah, just because we also set straight away. That one. Right, so we'll rebuild. Do we need to do a little flushing? Yeah, we needed to do a little flush. Cool. So now at this point we can now flush things up. So there's also the case of where the cursor is. So I think I want that sort of thing. Not that one. So cursor, which we don't actually have at the moment, but we probably do need to require where the cursor is, because the cursor will change about as we kind of go and do things. And so to store the cursor, all we really need to know is the X, Y of where we are. Saying that didn't I don't know how you find out about that. But yeah, anyhow, it's pretty much just a we could probably have an anonymous struct in here, and it will have a size t x and a size t y, and it will have a cursor. That's just what our cursor is, and it might have other things like type of cursor at some point, which is a thing. Like you can, I mean, at the moment it's a big square block that is blinking. If I go into insert mode, it's now a thin bar that's blinking. So you can have those types of attributes on your cursor. But to start with, we need to make sure that our cursor is in the right place. Now, this will start off zero-based, which is a little annoying because like everything else is, we can kind of assume that it is right. So I think if VT cursor dot X and VT cursor dot Y perhaps if yeah, what am I thinking? Perhaps if we don't have a valid cursor at the moment, we should probably reset it to null. But I think this shouldn't really be happening in the cursor. Like that sort of cursor check should probably go in every time you touch it, and also perhaps if you resize, which this should pick it up on the first thing. So then we can have cursor.x equals 1, and then find the x and replace that with y, and that can be that. Right, so then here we can trust that cursor. So we can just go to VT cursor x and VT cursor y. And that's just what it is. And then we can go hey out, we don't like that. So I wonder if this go to we can just assume that it is an int, because we know that that will be an int. Cool. So then now we kind of need to offset the cursor based on our thing. So I guess we need to do something like that. And then this is where the cursor is for our thing. And it is a solid block cursor, just by default, I guess. So what now? What now? I was going to do print, wasn't I? And I think that's kind of a good thing to kind of start on because it's easy. So in here we can where do we get print? Print. We don't have a print action. So we can do something like that. And this was unit 8. And like, it's really a chart at this point. We are asserting that in a chart, I think. So at this point here, if not VT, we should probably return. If if not is print. So what is print? Including space. So do I want is graph? No, I think is print is the one. So is print is what we want. Do something like that, and then pass in the input. Cool. So at this point here, we need to do a few things. We need to update the fact that we've now read a character. And it could be almost cool to know which key was read and have a kind of buffer of keys that are read. But for now, we'll just kind of update our display and that should be that. So what would we do? We would check where the cursor is at the moment if we are on a line. So I think this print, this is that's all this printing things. So print so this kind of say what happens on each of the things, character sets. Let's go chapter 7. A lot of things in this. Character sets, right? 7.1. You is this? No, that doesn't help. it gives like not a page number. So it was called character sets. That was just a. I thought that was just a chapter name. Right, so it was like chapter 7. That's the fancy stuff. Character sets 7-1. Like, where are we looking? 13, 10, 6, 11. Alright, golly, this goes through and tells you about what they will look like. Um, um, does not really seem like it's doing it. It's more about telling you how to make the things. Cool. We'll just do it on Hunt. So we have a few edge cases. If we so VT cursor. So I believe cursor should be just set up as soon as we resize window. Because we do this cursor check here. And like a resize window, should we not resize if it's the same size as last time? Do something like that. If new size not equal or rig size, and then do something. In fact, if it is equal to new size, then we can probably just return quite safely at this point here. Otherwise, we should go and do things. Cool. So in this print, I think we shouldn't need this, but perhaps just in case. I think we should, because every time a resize happens, this should happen, and the cursor should be at a reasonable point. So, if the x is equal to t window dot ws col, that means that we're at the edge, and I think I just want to do a little note. SDD air at end of row, and we can do a little thing there. Cool. So at this point here, we should kind of want to display it as well. So we would have VT cursor dot VT cells at VT cursor dot int times VT window. Actually, this is Y window dot WS. So we're going across that many columns, and then we're also going to add on whatever our Y portion is, X portion. So this is going to be the current cursor that we are currently sitting at. And so I think we need to account for the fact that it is 1 based, not F10 based, but 1 based. And then we can minus 1. So that is the cursor that we're currently at. Now, what we think that when I make this a few, it's something like this, and I'll just do that. So in our structure, we have a cursor and a cell should be used. So I kind of want to have do something like that. And then we can cell used equals true, because we're now putting a character there, and the character is just going to be our input. Our attribute is going to be kind of whatever's in the current attribute. So we almost need to have a current attribute. Yeah, I think we need that. Right, so that's going to be that, and then we need to kind of means we need to go to the next line, but then if that next line, if we're already at the bottom, then we need to scroll. So if VT cursor dot Y equals VT window dot WS row, then fix me scroll up, I believe. Otherwise, we're just going to plus, and X will set to 0, and the reason for that. So once we set it to 0, we're going to assume that kind of want this to be uninput. So yeah, I think that is roughly what I want at the bottom screen. So we'll set it back to 0, because when it gets out, it will increment. But if it wasn't at the end, it will increment anyway. And it will only increment Y when it gets to the end. And when you're at the bottom, it will do a different thing. We don't have scrolling at the moment, but that's all right. We called it attribute. I think that is a bit nicer. So C type will do C type H, do that sort of thing. And so now if we do things, we're doing a lot of state changes. So what I might do is just output that to a temp file. And we can source personal VT, and if we tail minus F temp, we can kind of see what is happening. So if we do A, it's still printing over there. So VT process, so in this, we want that to has to be air, and same there, and same there. So after we do that, I think we want to go like VT dirty equal true. Is that kind of what I want? And then we have just dirtiness status, and then if we after we process something, which does a lot of things, if after we process something it's dirty, if maybe we just want so we had a draw window. This should probably be a VT draw window, and that should probably also be a VT resize window. This should probably be a VT setup IO. Just be a bit nice with everything and whatnot. Cool. So in that case, we want to do this draw window, and we only really want to draw if not VT dirty return. And whenever we resize, we should VT dirty equal true. And then in this VT draw, we should also VT dirty equals false. And so now we should only draw when we're dirty. And so after we draw a cell, we should do that. So I wonder if we don't want to actually do that there, but in this main loop, we can handle a signal, and we draw a window if need be. And if not, we should potentially even have unreachable statements if not VT, depending on how much we want. Right, so we never actually added the dirty, but we added the dirty there, and it should default to not dirty, but when we resize it should become dirty. It did not become dirty. So resize did all of that. Maybe I do want to redraw inside of resize, which would for window. So this one here, don't do it in there, but you do it in here. Uh, um, and then we should just draw after every like that. Looks cool. Not printing anything. Well, we are printing stuff, but we're not actually printing it, if that kind of makes sense. Because in this draw window, we never actually we get the cursor where we want it, but here now we need to kind of go for x equals 1. Well, actually, we want to probably do something like that. So if we VT, this is going to have a cell, and we have a cell equals this statement here. And instead of this, we'll have y minus 1, and then this is going to be x minus 1. And then that will be our cell, and if cell used, then we almost need to check whether it's different to the last attribute. So the last, we have attribute, we have a few attributes. So where do we use that? We have a current attribute, which I guess is the current one that's in our buffer, that when we write a new key, that's what it will be. And that's checked at that point there. But I guess we probably want to last attribute, and it should probably just be the default. And this won't let me do that. So at this point here, we would want to set whatever attribute. So maybe I'll do unequal set attribute. And they'll require kind of looking at things. And this current attribute, I think, needs to be like a enum. Attributes. and we can just have a none to start with. But I think that's kind of what it should be, and then we can just check its first ints rather than going and destructuring stuff. And it will just start off with none at that point. But that kind of means that this isn't a structure anymore. So we probably just want this to be VT attribute none, and that's the default. And then we can kind of add stuff to that, and we can use like an X macro or something to kind of specify that. Right. So if we are used, we've now set the attribute somehow. So now we can probably go so if printf. So we probably want to go to wherever we are, so x, y. We can just kind of do that. And then just print a printable character at that point. And I guess knowing where we last were could be useful as well, because we could make use of like we could make use of whether we were last. In fact, yeah, we can do this if x is greater than 1 and if that value there, then if x is equal to 1 or the last one wasn't used, then we want to go to wherever we want to go to. And that way there we aren't putting out like heaps of go-tos for every single one. Like if you have 10 in a line, it will just do 10 in a line. Right, so this does not compile. We can probably go through all these things. It doesn't like this. That's because we're not closing off all of these things. Last attribute we never found. Yeah, because this we want to be the last attribute because we're now displaying it rather than storing. Cool. So now this gets a ASAN report. That's quite fun. So we're reading, and it's just after a heap thing that we resized in. And it's just after. Just the error try so the and we can see where x and y is at that point there, and so if we do that we should get so you can see we are trying cells or blah 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 and we get like 111, which I guess is we've gone to the 11th line, but like perhaps we don't want to do that, in which case why did we want to at that point but not this point? and we can probably pass in the VT window dot ws and we'll do row first, and then VT window ws hold for the second one. And so if we go to that, we still get this. Not to change this there. So it's just after it did the 10. So I feel like yeah, this is meant to be rows, and that's meant to be columns. And we have rows by columns. Yeah, so um, something like that. So if we did this again, we are now getting stuff. Cool. If we just reset that and we maybe do that because that's noisy. So now if we run this again, A, B, C, and you can see it's printing, but it's printing not to the right point. Because now we need to at this point here, we want to +3 and +3 there. Same with that tree, same with that tree. So there's a few places where like that's 3 and that's 3 plus 1, that's 3 plus whatever. This 3, all these 3s are kind of magic values of this is how wide my gutter is. And I use it down here as well. It potentially could be laid out better. But now if we kind of do this, and I believe if we get to the end, it wraps around. Now I don't know whether it should wrap around straight away, if that makes sense. Like, so if I just look at cat V, if I go to the end, it doesn't wrap around straight away. Important to notice there. But then the next one does. So it's kind of like it knows it's about to wrap. And potentially some of these documents kind of tell you, but I'll see how it is. So that means that was where we print, wasn't it? When we do this VT print, we kind of had that when we increment this. Now, it did tell me about end of row, didn't it? I wasn't actually checking exactly for that log, but like if we get up to that point there, yeah. So at end of row, I think I don't want to kind of set the cursor. I want to set the cursor as it's like a wrap pending. So I think I will have a little look-see for that. So in here, we'll wrap pending equal, well, it'll default to false because I zero initiate everything. So at this point here, I kind of want to go VT. Perhaps it should even go into there. cursor dot wrap pending equals true. And so if that is the case, I think I don't want to do any of that, but I do want to do it up here. So if VT cursor dot wrap pending, then I want to do that wrap. Come back. Otherwise, I just want to do that sort of thing. And in that case, I want to make sure it's set to 1. And if we're at the end of the screen, then we need to scroll up. Cool. So, and at this point here, VT cursor dot wrap pending equals false. And we might break out some of this stuff because other functions might display things to the screen, which see how that goes. But so now if we kind of get to the end, we don't move, and that's exactly what we saw here. We got to the end and the last character displayed, but the cursor is displayed on top. So if we go back here, and now if we go to another one, it should go to the next line. And I believe if I like resize, should kind of do the trick, but it hasn't because it's lost some it's lost data. So yeah, like if we that didn't really do what I wanted to do. Ended up bullets at some point. We got an escape character. It's kind of interesting. So it's I don't know. How do I go and do things? I could probably do a sequence from the to something like that. It's kind of lost all the input because we don't have support for line feed. Is that what the issue is? Yeah, so maybe if we it's not what I wanted. Excise that and then pipe that to 1 out and then 2 temp just TP, that sort of thing there. And like potentially we can even T minus D, get rid of that new line. Now we get leaks. Oh, leaks are kind of interesting. So we get a leak in that resize, and it's when we get EOF. So with that EOF, that's just in the main loop. We return from the main loop, and in that main loop, we should so at this point here, if VT VT.cells, and we just want to free that. And perhaps we'll even set it to null just in case something does pick up this. And that way, we should be able to get that, and we don't get that free. Cool. So this is kind of doing what I want to do. What I kind of want to do now is I wonder if I can do that sort of thing, and then just do like a big sleep beforehand, and that way we can perhaps even get that sort of resize event. Yeah, we did get resize events there, and we just lost so much data. Interesting why we lose so much data. So in the resize window, that's where we should be doing this mem copy. So the mem copy, we want to do a mem copy of the min size times the size of whatever the size of the thing that we're copying is. And then that way we can do that. And it lost that 96, but it hasn't lost everything, and it kind of regroups over. And if we that looks nice. And perhaps when we restore IO, I wonder if that should kind of clear the screen or something like that, just so we're not kind of dumped out into the middle of that. We could make use of the alternate screen, which is just another screen buffer that you can use. And so then you can exit out of the alternate buffer when you end. But I don't know. I think where it is at the moment, I'm reasonably happy. We got a size, we got the kind of borders showing. We have the print action working, or the current character set. I haven't even thought of how I'm going to implement other character sets, but that's all good. And yeah, the resize is working, the redraw is working, so we can kind of print stuff out. The next kind of stage would be perhaps found out in another video. There's a few options, and I don't know which one I'm going to commit to just next. But yeah, this has been kind of great. I've got a more done. I'll add all this up. As this is kind of what we've done. We did do like a big shift, but made that commit a bit dirty. I wonder if I go back to having all of this. We can do stuff like this. Yeah. Do something like this. And then bring that back. Yeah, and then you can see what that looks like. It kind of change that. So get diff cached. That's what I want, cached. just in case you're feeling like it. So now we have just the print and kind of showing what we do. We can probably take out that hard-coded SD out. Which is just there. So now we can kind of commit up that is just a nice small commit. Get print action working with border and resizing. And I think that can be that. But yeah, if you are interested in this project, please do let me know, and I'll try and do more. But for now, I think I will leave that, and I'll get back to it another time. See ya.